right, welcome to the second part of Lecture 11, where we're going to talk about XML HTTP request. And this is the magic that allows you to push and retrieve information from other resources, other websites, etc. So this is very powerful for obviously accessing data. So this is something you'll more than likely be using in your collaborative projects for fetching data from a server and being able to display it on the client, etc. So we will be talking about this, how you can actually set it up, and a few of the gotchas that JavaScript has with being able to transfer and push data to and from a client. So let's get this going. Once again, here's a few links. We have the Mozilla tutorial. Once again, fantastic stuff. Jibbrings.com and OpenJS XML HTTP request example. These are all great links. You can check them out if you have questions. So AJAX is a popular term that's thrown around. It stands for Asynchronous JavaScript in XML, and that's technically what we're doing with XML HTTP request. We're using it to asynchronously fetch data. And as this says right here, we send data back and forth to the client without having to actually leave a web page. So way back in the day, anytime you wanted to get or retrieve information, you had to leave your web page and go to a new page. However, with the fantastic world of AJAX, you can stay on one page and go and retrieve information. And AJAX, it's kind of getting old now, maybe about 10 to 15 years old now, but it was a really big deal about in the early 2000s when Microsoft Outlook first did it for being able to get and retrieve information about your emails. So if you got an email, Microsoft Outlook would use HTTP to go and ping the server and then pull that information and update it in your inbox. The next really big player was Google Maps in 2005. And Google Maps, as you well know, goes and retrieves maps for you. And the way that they use AJAX is they have each part of the map sliced into tiles. And by using AJAX, it would go and retrieve each individual tile. And as you scroll left or right outside of your viewing zone, you would go and using AJAX go and retrieve other map tiles. And this allows you to continue pulling information without having to actually go and reload your web page, etc. And Gmail in 2004 was also a big player with AJAX. Now it's kind of exploded and is all over the web. So how does AJAX technically work? Here's kind of a high-level diagram. And what we do is inside our browser with our JavaScript file, we are going to create an XML HTTP request object. We're going to fill it out with all the necessary information, such as where we're going to send it to, where we're going to retrieve information, where we're going to post information, and then we're going to kick it off. And AJAX will then send it off across the internet, more than likely hit a server, and the server is going to process that information just like if we were actually going and entering it in our URL bar. It's going to bundle up a whole bunch of information, and it's going to send it back. And the browser is going to get it, and using the same object that we use to kick this whole process off, it's going to have some sort of result. It's going to tell us whether the request was successful, and if so, we can go and process the response data. Using that data, we can then update our web page. So for example, we could go and retrieve a whole bunch of movie titles and then populate our web page with said movie titles, images, etc. So this is how it all works, and we're going to step through some examples, and you guys are going to see a little bit closer how it all gets going. So without further ado, here is kind of the meat of XML HTTP request. Something to note is if you're trying to make this work for IE5 and IE6, which you probably never will be anymore, there's a slightly different method. However, for newer browsers, it's very simple. All we're going to do is actually instantiate a new XML HTTP request object, and in this case, we're going to store it in a variable so we can reference it over and over again. So very simple, easy to do. We now have an object to enable us to do this kind of networking, pushing and retrieving of information. Next, we have to actually initialize this object with useful information such as where we're going to go get this data, what kind of HTTP method we're going to perform, etc. So to do that, we use the open method, which is a part of the XML HTTP request object. So if we look inside the API for the open method, it takes 5 parameters. The first one is a string, and it's the HTTP method that you would like to use for this request. The next one is a string URL, so what URL do we want to go visit? And then the third one is a Boolean for whether we want to make a synchronous or an asynchronous request. And then these last two is if you have a secure server and need to provide a username and password. For all of our examples, we'll just be focusing on these first 3 parameters. You don't even have to include these last 2, they're optional. So talking a little bit more in depth about the first parameter, which is a string, you should know from our HTTP lecture that we had when we went over forms that there are a few different methods that we can use. One's a get. Get is for retrieving information. Post is for creating information. Put is for updating information. And delete is for deleting information on a server. Hopefully, as you learn more about HTTP and REST, you should be very familiar with these and know how to use them. So that's what I'm going to say about those. Second, we have the URL parameter, which was a string. So www.google.com, lyle.com, wherever the server is that has information. That's the URL. Next, we have the third parameter. And the third parameter is very important because JavaScript allows you to do 2 different types of request. One is called asynchronous. And hopefully you know the definition of asynchronous, but what that does is basically it's going to kick off a separate thread and go do all this HTTP work in the background. So you're going to kick off this request and continue execution while in the background this HTTP request is going on. Whenever the HTTP request finally completes, it's going to sync back up with the main thread where you're executing other JavaScript logic, and then it's going to allow you to update your web page. So asynchronous requests are really handy because it's not going to pause execution. It's not going to delay the user from being able to interact with a web page or anything like that. So when you have large amounts of data that you need to go and fetch, you always want to use an asynchronous request. If you don't, your browser's going to act like it's broken and pause, and the user's not going to be able to interact with the user interface, which is bad usability. And hopefully, based on what I just said, you know the flip side, which is synchronous. Synchronous is going to pause right where you're at, right when it says open, and then you're going to send that request. Your JavaScript is going to stop and wait. It's going to wait until it goes and gets all the information from the server and returns. So once that information returns, then your script is going to continue executing. So like I said earlier, your entire file is just going to stop. Your logic's going to stop executing, and you're going to have to wait. So if you have really short little requests, you can sometimes use synchronous, but for most cases, I'm always going to recommend you use asynchronous. And like I said, these last two we're probably not going to worry about too much. It's if you want to provide a username or password for your request. So here we're going to build on our example a little bit more. Here we are going to create that object like we've already done, and now we're going to open it up. And in this case, we're going to do a get. We're going to retrieve information from our URL, which is www.google.com. And then the third parameter is false, meaning we are sending synchronous request. So we're going to pause until we fetch this information. Now, something I'd like to note is if you open up your browser right now or open up JSFiddle and you try to run this, you're going to get an error. And that is due to some kind of gotcha with JavaScript that I'll talk about in a little bit. And it has to do with us trying to access google.com. And I'll talk to you about that in a little bit, but I just want to let you know before we get too deep. Now, finally, we have created the object and we've set it up to tell it where it needs to go and how it needs to do it. And then lastly, we need to send it away. So if we don't call send, nothing has really happened. It's not until we execute the send command that we're actually going to go and retrieve this information. So at this point right here, since we're doing synchronous request, we are now going to pause logic until the server returns information to us. Now, we've sent off this information. How do we actually process the result? Well, there's a little bit more work that we need to do. And what is necessary is not every single request you're going to send is going to be successful. Sometimes you could have a URL which doesn't work. Maybe you've used an invalid URL. Maybe the resource that you're looking for isn't actually there. So what HTTP provides is status codes to tell you how your request was handled. Perhaps the location hasn't been valid, it's been redirected, etc. You can use HTTP status codes and see if everything was okay. If things worked out for us, we can then process the response text appropriately. Else, we could read the status code and determine possibly something has gone wrong and handle it successfully without kind of blowing up on the client side, which would be bad. So, kind of a high-level overview. Whenever you have a 200 code from HTTP, that usually means things are good. And for the most part, you should always receive the status code 200, meaning the request was successfully processed. Everything's great. So what we want to do is, after we send our request, we're now going to use an if statement and check the status variable, which is associated with this XMLHttpRequest object. If the status is equal to 200, meaning the request was successful, we can then process the response text, actually what the server sent back to us as a client. Something that's important to note here is some people are like, well, how can we run this request right here once we call send? Isn't this just going to continue to execute immediately, and the request isn't actually going to have a chance to fetch what it needs to? However, that all kind of relies on this third parameter right here, which is synchronous, meaning we're going to pause. So by doing this code right here and having it be synchronous, we can guarantee that when this line of code is executed, the request has successfully been transferred and we have a result. We don't know whether the result is successful or not. That's what we're doing right here with this if statement. So that is important to note. When we do an asynchronous request and have this third parameter be true, we can't just do this kind of logic. We need to set up a callback so we can be notified when the server has given us logic back. A response back. So using this example right here, we're going to use the console.log and just print out what the server sent back to us. So more than likely, this could be HTML. It could be a web page, so we could print out that. In most cases that we'll be using it for, it'll probably be some kind of data like XML or JSON, and then we can use that data to process it accordingly. So here's a complete example of an XML HTTP request. So something else to note about the XML HTTP request is that it has a few different variables and methods we can use. One is the status, and that returns, as I mentioned, the status code. And if you look at the HTTP spec, you can see that there's, I believe, about 10 to maybe 20 status codes that can tell you different types of things. Next, we have the status text, and that'll give you some status text associated with the status code. Most of the status codes have English translations to them, so that's what the status text will be. It'll be the English result of that code. Next, if for some reason you need to get the results header information, we talked about headers a little bit, you can do that by using the get response header, and you can specifically look for a response header. Next, you can call the get all response headers, and that will return every single header from the response message. So these two methods are a little bit more advanced. You may or may not be able to, you may or may not need to use those. So talking more about the response, as I mentioned, HTTP, you can transmit all types of data. So we might be receiving HTML, we might be receiving JSON, we might be receiving text. Also, you can get array buffers, blobs, which is just large chunks of data, etc. So if the server that you're requesting information from returns different types of data, usually in the header, it'll say what type of data it's transmitting. So what XMLHttpRequest objects will do is provide this response type variable, and it'll tell you what the server sent if the server was nice enough to provide that header. The response, that'll give you some response entity body, not too important. The response text, that's what we really care about, and that's the body of the message. This is the creme de la creme of what we're looking for. Also, if the server returns XML, you can use the response XML variable. Just FYI there. So here I have this set up. Ideally, what I want you guys to do right now is to pause for a second, and using the code that I showed you, I would like you to set up an XML HTTP request to go and get information from this URL right here. And I've already set up a basic JS fiddle for you to start with. So let's take a look at that and see what I provided you. And as you can see right here, I've already given you that URL, so you don't actually need to copy it from the presentation. All you need to do is actually create the XML HTTP request object, use the open command, and then send it. And I've already set up the way to handle the response. So pause the video for a few seconds and see if you can figure this out. Once you figured it out, or if you get stuck, you can continue. So I'm going to wait for a few seconds, and then I'll give you an answer. All right, that was a few seconds. So what we need to do is create the XML HTTP request object. So we're going to create a variable, and we can give that name anything that we want. I usually use request. And what we need to say is new XML HTTP request. And since we're creating an object, just like in Java, we need to use the new keyword and also the parentheses. And now we actually have this object created. However, this object isn't set up in any way, so it's not actually doing anything for us. So we need to call the open command. And if you remember, the open command takes 3 parameters that we care about. One is the HTTP request type, and since we're trying to retrieve information, we're going to do a get. Next, we need to specify the URL where we want to go and get information. So I already have that taken care of right here with this URL variable, so we're just going to put URL right here. Last, we need to specify whether this is a synchronous or asynchronous request. And since I'm handling the logic immediately after this code right here, I should probably do a synchronous request. We're going to pause and process this. So I'm going to specify false. So now I've opened up the pipe. Let's run this and see what happens. And as you can see, nothing has happened here. And that's because I haven't actually sent it. So I need to call request.send. And hopefully now, when I run it, boom, we see a beautiful result of all this HTML information. And so if you're a little confused with what happened here, is we set up a get to retrieve information from this URL. And then what we did is we sent that request. Since we did synchronously, we paused. We checked the result code. It was successful. It was equal to 200. And then what we're doing right here, hopefully you guys know this from our DOM workings, is we're using the DOM to access the body HTML element, and then we're accessing its inner HTML, so what's in between its tags, and all we're doing is setting it equal to what the server gives us. And the server is returning HTML, so we're putting HTML inside the body element, and what that's going to do is display the HTML from this web page. So hopefully none of that was too difficult. So moving forward, I just showed you how to go and actually get a web page. However, hopefully you guys know that sometimes HTTP requests are a little bit more difficult than that. Maybe you want to send some information along with your request so you can get specific parts of information. So you're going to do a get request with some query parameters, if you will. In addition, you can post information with query parameters. But what's important to note is if you do either of these, you need to send a key value name pair along with your HTTP request. And this is useful for getting specific pieces of information. So like we talked about in class when we did the Google example, whenever I sent out a search, it put that search query in there. Also, if we wanted to filter it to YouTube, it would add a YouTube query filter. So using the key value name pairs is very important. So here's a typical example of a filter that we could send to a web page. In this case, we have 1, 2, 3, 4 key value pairs. And you can tell that because it's been key value pairs are separated by the ampersand sign. And what we're basically sending is name equals Tim, last name equals Drake, age equals 17, alias equals Robin. So we're searching for a specific person with an alias and an age. And so how can we use this key value pairs and send it along with our XML HTTP request? Great question. Well, let's kind of think about how Google usually does it. And with a GET request, what usually happens is this information that we're looking at right here is appended to the URL that we're sending or trying to get information from. And so if you look right here, all we need to do is append those key value pairs to the URL, but the key part here is to have a question mark. That question mark is very important. Anything that follows the question mark is known as query information. Super duper important. So how do we get this done with XML HTTP request in JavaScript? It's very simple. All we need to do is, once again, we have our URL. Next, you get your parameters, and we'll just have our entire string right here. Maybe you have a form, maybe you're getting some kind of input, so you might need to do a little bit more extra work, such as retrieving those name value pairs and concatenating them all together to get your params. Whatever you need to do, no big deal. But then the key step here is, in addition to getting your key value pairs, we need that question mark. We super duper need the question mark. So what I'm doing here is, for the URL parameter, is I'm concatenating our URL with a question mark and all of the parameters, and I'm sending it away. So here, we've successfully done a GET request with query parameters. Fantastic. Once again, if you were to run this, because we're trying to access google.com, it's not going to work out, and I'm getting close to explaining why that is. Next, let's talk about post requests. Posts are a little bit different. Remember, you use post for creating information. And usually, the information you create is private, or you want to kind of keep that information a secret. And so it's a little bit different than a GET request because GET puts key value pairs in the URL. Post puts that information in the body of the HTTP request. So we have to set it up a little bit differently. Some other things that are important to note is with a post, usually you send a little extra information, such as what type of data you're sending and the length. So I'll show you how to handle this. And so here we have our URL again, still google.com. We have our parameters. However, something that's important to note is our second parameter is only the URL. We're no longer concatenating it and including the question mark and the params. That's different with post. What we do instead is we need to set up the header. This is that additional information that's needed for the post, and we're specifying what type of information we're sending. So once you learn a little more HTTP, you know that the content type describes the information that we're sending, and there's several different types. There's XML, JSON, and there's several more. But a very important one that is used by forms is application/x.www-form-url encoded. And whenever you send a form from your browser to a server, this is the type of content that is being processed. So that's what I like to use for these types of things. So we set this up. This is going to send the appropriate headers to our server, but we also need to include our parameters. And so here, what we do is put our parameters as a part of the send method. Before with get, we didn't do that. So now what we've done is successfully posted some information. All right, so if we click on that link, we can now see we have this post example. And if we set it up and click run, we're going to see that we're sending some parameters. We're sending fname equals Chris, lname equals Rayleigh, age 26, favorite food turkey. We're going to run this. We're going to see what happens. And if we come here to our request, we'll see that we don't have any get parameters, which is true because we're sending a post. But if we look in the post section, we see that we've sent all of this information to it. So this web page that we're using is something that I've shown in class. Basically, just echoes out all of the information you send to it, and whether it was a get or a post. So we've successfully now done a post. So great. And here's a quick code snippet, obviously, about that. So moving along, we now know how to do a get request. We now know how to send parameters with a get. We now know how to do a post request. We now know how to send post parameters. You guys are becoming XMLHttpRequest experts. So if you would like a little bit more in-depth example, you can click on this link, but not necessary. So I told you about asynchronous requests, and I said that's what you guys should more than likely be using, but so far I've only shown you synchronous requests. So let's talk about the other side. Once again, synchronous requests are bad because you're going to pause code execution, and this could be bad, so it's not practical. But asynchronous, like I said, launches a background thread and lets you process this work on the network while you can continue execution on the front side, so there's not going to be a pause. So this, as I've bolded right here, should be what you're using in your code. And obviously, since it's doing a little bit of extra work for us, we kind of need to set things up differently. So what you need to do is you need to create an event handler. An event handler is what happens when you register an event with an object, and that event is triggered, your code is going to be called your handler. And event handlers are very important in JavaScript and several languages because there's all types of events. There's when a user presses a keyboard button, when they click a mouse, etc. We can register and listen for these type of events and have handlers which handle when these events are triggered. So in this case, we want to be notified when our XMLHttpRequest returns data to us. And what we're doing right here is we have an onReadyStateChanged handler. And this will be called when the ready state changes for our XMLHttp request. And if you dig a little bit deeper, you'll look inside and see that there's several different states for a ready state. There's 0 through 4. And it can tell you that, hey, this hasn't been sent. Hey, you have a request that's open. 2, you've received some headers, but you don't have the body yet. 3 means we're actually processing all this data. And 4 means this request has been processed and it's done. The operation's complete. So sometimes you might care about some of this other information, but for the most part, we care about this ready state equal to 4. We care about that the operation is complete. So what we're doing is, once again, we're just going to have a URL, nothing new here. We're going to create a new XMLHttpRequest object, still the same code as our synchronous request. But what we're doing is, with our request object, we're setting up an event handler to process the state changes. And to do that, we just specify a function and the implementation of that function. So we just say, call this function when ready state changes. And then we process it accordingly. So here's our callback method. It will be called when ready states change. Next, we call request.open, and we're going to do a get with our URL to google.com. And here we have to specify that we're doing an asynchronous request. Asynchronous. And then we send it away. Now, some people might be confused here because, hey, we set up all this logic and to be as a callback, but then we call send right here. How is JavaScript smart enough to know that this needs to be called? When we processed this code earlier, people think, code starts at the top, executes to the bottom. However, once you start working with event listeners, this code is going to be kind of cached, and whenever ready state changes, it's going to go and be fetched and called. So despite the fact that this is declared before the send method, believe me, it will still be called. So that's important to note. And here we can run the JS fiddle again and see, you can see right here, it's going to return the exact same information as our synchronous request. However, we're now doing it much more efficiently and processing it in the background because we have this parameter specified as true. So it's all nice, very nice stuff. I'm going to talk to you now about the bummer, the downsides of it. And so as I've shown in my examples, I've just, for brevity, used www.google.com. And it's unfortunate because with JavaScript, it has a concept known as cross-domain request. And what that means is you have your HTML set up on server A, and now you're trying to go to a different server, server B, and request information. And JavaScript, by default, doesn't allow you to do that. So you can't just go and fetch information from any server in the world that you want. What JavaScript does allow you to do is request information from the same server. So anything that's on the Lyle servers, you can go and request and successfully fetch. So from your Lyle server, you could go and request information from my Lyle website. So if you wanted to create an XMLHttpRequest request to go and crawl my webpage, you could successfully do that because we're all on the same server. Now, that is kind of a bummer, and there's a few workarounds for doing this. One is if you go to a different type of language, such as PHP, Python, etc., they don't have this concept of disallowing cross-domain requests. They don't care. They just go and do it. Other things you can do is there's a library known as JSONP that will allow you to do cross-domain requests. And lastly, what you can do, which might be preferable, is you can set up a special header for your server that when you go and process information, you can return a specific type of header, which says what you will allow third-party servers, other servers, to do when they're trying to access your information. So what I've done behind the scenes is, if you noticed, we're using JSFiddle to access the Lyle server. And from what I told you, technically you shouldn't be able to do this because lyle.smu.edu is on a different server than JSFiddle. However, I've set up this special header which allows me to communicate with other servers, and this special header right here is this HTTP accept method. And what I've done is I have star right here, meaning I'll accept any request from anybody. So by setting up the special header, I am allowing anyone in the world with their server using JavaScript to successfully go and fetch information from me. So that's kind of the bummer of JavaScript XMLHttpRequest, but also a few workarounds that are important to note. So with that information, that's about all I have for XMLHttpRequest. What I recommend you guys do is, if you haven't already done so, is to go and actually do a few practices examples. Once again, check out the Blackboard quiz. You're going to have to submit some code on how to do that. So I hope you enjoyed this video. There's one final video, and we'll talk about JSON. So I'll see you in a little bit.